This lesson will explore the various types of cables and connectors used to connect audio system devices and explain fundamental audio system impedance. Audio system devices are connected together using cables with various types of connectors. Let's begin by identifying the various items that compose a typical cable. The jacket serves two purposes: to protect the cable from everyday abuse and to house the various wires that compose the cable. Not all cables have a jacket, however most found in pro audio do. In some cable there is a metal layer inside the jacket known as the shield, which helps reduce induced outside interference from entering the wire beneath. Next is the wire or conductor, which is the actual portion that transmits voltage. Surrounding the conductor is its insulation, which is typically rubber or plastic, which prevents multiple conductors from touching. There are various types of cables found in an audio system, each of which are either shielded or non-shielded. Shielded cable prevents outside interference from penetrating the cable and introducing noise or RF into the system. Shielded cable includes one or more insulated inner conductors plus a shield wire. The shield is an uninsulated conductor and a braided wrap or foil that surrounds the inner conductors. Shielded cables are used throughout the audio system, wherever mic and line level signals are found. Generally, loudspeaker cables do not require shielding. A good rule of thumb is that if the cable is used to connect anything other than a loudspeaker to a power amplifier, it needs to be a shielded cable. Non-shielded cable is used to connect loudspeakers and control systems. There are some instances where shielded loudspeaker cables are required. Unshielded twisted pair cable, also known as Cat5, does not include a shield, but by the nature of the number of twists and wraps within the cable jacket, it rejects outside interference and thus performs much like a shielded cable. UTP cable is used to connect computer networks and digital audio control devices. Audio cables vary by the numbers of conductors. The most common cables include single conductor, two conductor, and multi-conductor. Single conductor cables include an insulated center conductor and a shield. These are typically used as instrument cables and unbalanced signal cables used with CD and tape decks. Two-conductor cables include two insulated conductors and are either shielded or non-shielded. Shielded two-conductor cables are used for microphone and line-level signal transmission and include a non-insulated shield conductor. Non-shielded two-conductor cables are used for connecting power amplifiers to loudspeakers and do not include the shield conductor. Multi-conductor simply means multiple single or two-conductor cables are bundled together in one PVC jacket. Multi-conductor cables include both signal and loudspeaker types. Gauge is the term used to describe the diameter of the cable's conductors. The conductor size is important in regard to signal strength over distance. For instance, a low-voltage, low-impedance signal like microphones can be run through a small gauge cable a fair distance before signal loss becomes a factor. The symbol for wire gauge is AWG, which is short for American Wire Gauge. Consequently, loudspeaker cable is typically larger due to the high voltage produced by the power amplifier and the distance required to reach the loudspeaker's input. When purchasing loudspeaker cable, keep in mind, the larger the gauge, the better. For example, a 16-gauge cable is adequate for runs up to 25 feet, a 14-gauge cable up to 100 feet, a 12-gauge cable up to 200 feet, and a 10-gauge cable for runs over 200 feet. It is recommended a minimum 12-gauge cable be used for subwoofer loudspeaker systems no matter the distance. Constant voltage loudspeaker lines, also known as 70-volt lines, do not require large-gauge cables. Typically, a 16-gauge cable is sufficient. Here are a few cable rules of thumb. All cables, other than loudspeaker cables, should be shielded. Do not use shielded instrument cables to connect monitor loudspeakers. The cable gauge is too small and will limit performance. Check all cables with a cable tester before energizing. This basic procedure will rule out simple issues and possible problems. Always roll cables properly before storing. Do not wrap cable over your elbow, as this can cause damage to the cable and extreme frustration. Audio system cables incorporate various types of connectors to provide easy connection of devices. The most common connectors include the 3-pin XLR, the 1/4-inch TRS plug, the Speak-On, the RCA, and the Stereo Mini or 3.5 millimeter plug. The XLR, 1/4-inch TRS plug, and Speak-On are the most prevalent in pro audio systems. The 3-pin XLR connector is a 3-conductor connector used for microphones and balanced signal cables. XLR connectors are available in 3, 4, 5, and 6-conductor versions. One key benefit of the XLR connector is its locking ability between male and female connectors. The RCA connector is the most common connector used with consumer-grade audio equipment, CD players, and tape players. Professional series CD players and recorders incorporate balanced XLR connectors. The 1/4-inch tip ring sleeve or TRS plug is available in both a 2-conductor and 3-conductor version and is mainly utilized for both balanced and unbalanced line-level connections. The Stereo Mini or 3.5 millimeter connector is used on most computer sound cards, laptops, and portable MP3 players. Like its 1/4-inch big brother, the 3.5 millimeter connector is available in both 2- and 3-conductor versions. The TA series connector is a miniature XLR connector. TA series connectors are used primarily for wireless lavalier microphones and are available in 3- and 4-conductor versions. Until recently, the 1/4-inch plug was used as the primary loudspeaker connector. However, Neutrik Speak-On connector has gained support and is fast becoming the most common loudspeaker connector used for both power amplifier outputs and loudspeaker inputs. Speak-On connectors utilize a twist lock configuration and are available in 2, 4, and 8-conductor versions. Balanced audio connections are the best method for rejecting induced noise and interference that enters the cable. Balanced connections use a shielded 2-conductor cable and XLR and or 1/4-inch TRS connectors. The 2 conductors both carry the audio signal, except one is 180 degrees out of phase with the other. When noise is induced in the cable, it is present and in phase on both conductors. The shield acts as a ground and drain wire for other noise rejection. At the receiving end of the cable, a differential amplifier inverts the phase on the out-of-phase signal and recombines the 2 signals back into one. When the phase is inverted, the once in-phase noise is now out of phase and is canceled out, leaving a clean audio signal. A 3-conductor cable and connector is balanced, while a single-conductor cable and connector is unbalanced. A microphone cable is balanced and uses a 2-conductor shielded cable and 3-conductor XLR connector. A guitar or instrument cable is unbalanced. It is made up of a single-conductor shielded cable and 1/4-inch tip sleeve phone plugs. Balanced low-impedance signals can be run over long distances, but unbalanced signal cables should not be extended beyond 25 feet. Unbalanced cables are susceptible to interference and act much like an antenna when run over long distances. Adapters are available to convert 2-wire unbalanced lines to 3-wire balanced lines. These adapters incorporate a transformer to match the impedance and balance the signal. The most common impedance matching adapter is known as a direct box. A direct box converts high impedance unbalanced to low impedance balanced. The most common use of a direct box is to connect keyboards, synthesizers, bass guitars, and other line-level devices into the audio system via an Xlr microphone input jack. Most direct boxes include a ground lift switch to eliminate possible hum and an attenuation switch to reduce the signal level from line level down to microphone level. The ground lift switch disconnects the shield from the signal path, eliminating multiple ground paths. Impedance is the resistance a device's input and output place on the signal path. It is important to match impedance when connecting devices in order to maintain proper gain structure and signal quality. Typical loudspeaker impedances include 16 ohm, 8 ohm, and 4 ohm. It is important to calculate the total loudspeaker impedance load before energizing a power amplifier. Calculating an approximate impedance load on a single amplifier channel is done by determining the number of loudspeakers to be connected and whether they are connected in series or parallel. If they're wired in series, simply add the impedance of each loudspeaker together to get your total. If wired in typical parallel fashion, and all loudspeakers have the same impedance, simply divide the common impedance by the number of loudspeakers. For example, if 4 8-ohm speakers are connected in series, the total impedance load would be 32 ohms. 8 times 4 is 32. If instead they are connected in parallel, the total impedance load would be 2 ohms. 8 divided by 4 is 2. Most power amplifiers are stable down to 4 ohms and many down to 2 ohms. This is important to remember when connecting multiple loudspeakers on a single monitor mix driven by a single amplifier channel. Impedance matching is easily maintained when proper cables and connectors are used to connect the audio devices. One should take caution when multiple adapters are used in an effort to make a connection. The use of a direct box is the most common impedance matching method. When splitting microphone or line-level signals to recording or broadcast mixing consoles, an active splitting network or splitting transformer should be used to ensure proper impedance matching, prevent console interaction, and possible device damage. There are various types of cables found in an audio system, each of which is either shielded or non-shielded. Shielded cable includes one or more insulated inner conductors plus a shield wire. Non-shielded cable is used to connect loudspeakers and control systems. Cat5 cable performs much like a shielded cable and is used to connect computer networks and digital audio control devices. All cables other than loudspeaker cables should be shielded. The most common audio system connectors include XLR, phone plug, RCA, and Speak-On. A 3-conductor cable and connector is balanced, and a single-conductor cable and connector is unbalanced. A direct box converts high impedance unbalanced to low impedance balanced. Impedance matching is easily maintained when proper cables and connectors are used. One should take caution when multiple adapters are used to make a connection. It is important to calculate the total loudspeaker impedance load before energizing a power amplifier.